Why did the student read the sign backwards? Because it was an inverse sign. And you're going to be learning about going backwards. Basically, instead of saying sine of an angle is this ratio, now we're going to say inverse sine of this ratio is this angle. And that's going backwards. So if you know the sides of a triangle, you can use the inverse trigonometric operations to find the measures of the angles. By the way, these inverse operations are also sometimes called arc. So you could say inverse sine, inverse cosine, inverse tangent, or arc sine, arc cosine, and arc tangent. You'll probably see arc more in the upper level math classes, and you tend to see inverse because the button actually looks like inverse on your calculator. So if I said if sine of A is x, and I wanted to find the angle, I just take the inverse sine of x, and that gives me A. Same thing for cosine and tangent. So x is the ratio of the sides of the angles. Do not mix up the angle with the ratio. You do only inverse sine of ratios and sine and cosine and tangent of angles. So let's take a look here. What is sine of 30 degrees? So I've got my 30, 60, 90 triangle, and sine is opposite over hypotenuse, so it's going to be x over 2x. Well, that simplifies. X divided by x is 1, so it's 1/2. Now here's the interesting thing. If you plug the ratio, which is 1/2 or 0.5, in your calculator, it can automatically give you back your angle. So inverse sine of 0.5 is going to give you 30 degrees on your calculator. Now this next step I'm showing you just to see that they are the opposites of each other. You're not normally going to have to write this. A lot of people go straight from, sine of x is this ratio, and they'll just do inverse sine right here. But it's not a bad exercise. You say inverse sine of sine of an angle. So if you actually put this in your calculator the way I have it here, you're going to see it's going to spit back the angle. Again, the main point I'm trying to make is that inverse sine is the opposite of sine. They undo each other, so that kind of like square root and square undo each other. Let's look at 60 degrees. Pretty much the same ratio. Cosine of 60 degrees is x over 2x, which is 1/2. If I put 0.5 in for inverse cosine, then I actually get 60 degrees back out. And the same thing. If I do inverse cosine of 60, I get 60. And the main thing I'm trying to show you down here is that these two operations undo each other. What is tangent of 45 degrees? Well, we know that it's going to be opposite over adjacent. So if that were my angle right there, the opposite is x. The adjacent leg is also x, so it's just 1. If you take inverse tangent of 1 on your calculator, it's going to tell you that it's 45 degrees. And same thing, if I do inverse tangent of 45, I actually get 45 degrees. These two undo each other. So what does an inverse trigonometric operation do? It undoes the original trigonometric operation to get back the angle. So we're going to find some missing angles. To do that, you highlight a known side on the triangle. Is it the hypotenuse, or is it opposite or adjacent to the angle you're looking for? Highlight a second known side. We will need two sides to do this. Is it hypotenuse, opposite, or adjacent? Depending on which two you have, it tells you what ratio you have. So you have opposite, adjacent, and hypotenuse. Or let me do that. Opposite, adjacent, and hypotenuse. If I have opposite and adjacent, I'll use tangent. If I have opposite and hypotenuse, I'll use sine. If I have adjacent and hypotenuse, I'll use cosine. So, determine which ratio, and that's what I was just going over, can be used with the two sides to determine the angle. And then use the calculator to take the inverse. You will need it to find the angle. So using the calculator. First of all, again, every time I've said this, make sure your calculator is in degrees, not radians mode. The default is radians, and that's, again, for your upper level math. If you need to, press the blue button labeled second, and then press the trigonometric ratio. So you are going to need to press second, and then you press the trigonometric ratio button. You will need either sine, cosine, or tangent. And above those ratios, you're going to see inverse sine, cosine, and inverse tangent in blue to match that second button. Enter the ratio you found above and press enter. So here, what I have is a 3, 4, 5 Pythagorean triple. Did you ever wonder what the angles were in this? We've never talked about them. So here's my hypotenuse. There is angle A and its opposite side and angle C and its opposite side. Let's go ahead and start with angle A. And I'm going to use tangent. I could use, since I know all three sides, I could have used any of the trig operations. So tangent of A is 4 opposite over adjacent, 4 over 3. Then I take the inverse of both sides, and these undo each other. So it's not really that they cross out, but they undo, like square and square root. So I'm going to end up with just A on the left side and inverse tangent of 4/3. Well, your calculator knows how to do that. It's going to tell you that it's about 53.1 degrees. So we can find out that for this, the long leg, or the medium side really, it's got this medium angle, 53.1. I can do the same thing for the other angle. Sine of C is going to be opposite over hypotenuse, so that's 3/5. And notice I'm using a different ratio. I could have done cosine or tangent. Take the inverse of both sides. These kind of cancel each other out. They undo each other. So you can say C is just the inverse sine of 3/5 of the ratio. Then you put that in your calculator and you get 36.9 degrees. And many of you are very bright and say, hey, Mrs. Overman, couldn't you just subtract it from 90 for that second one? And yes, I could have. But I want you getting some practice with the inverse functions. So now we're going to look at angle A and angle C in the 5, 12, 13 Pythagorean triple. So we got the 5, 12, 13. And so angle A and B and C. So first of all, hypotenuse is 13. There's angle A and opposite. Angle C and its opposite. So we'll say sine of A, just to give you some different practice, it's going to be 12 over 13. Take the inverse of both sides. So you get A is inverse sine of 12 over 13. You put that in your calculator and you're going to get about 67 degrees. Now I'm going to go ahead and do angle C. And angle C, let's use cosine for the fun of it. Well, since I'm doing cosine, 12 is actually the adjacent. So cosine of C is 12 over 13. So I'll take the inverse of both sides, and I get C is, and that should be cosine. C is cosine, inverse cosine of 12 over 13. I assure you this is the right number. It is 23 degrees. All right? So that's how you find angles using inverse operations. So for further reflection, what does an inverse operation do? I probably beat it to death for you. And how do we find missing angles using inverse trigonometric operations? Is it possible, by the way, do you think it's possible to have a ratio greater than 1 for sine or cosine? And this is a good point because if I do inverse sine of 2 and your calculator blows up, that's because you're trying to put in something that's not a valid ratio. Remember, the ratios for sine or cosine can be anywhere from 0 to 1, including 0 and including 1. But they cannot be greater than 1, and they cannot be negative. Which side usually goes on bottom for the ratios? Honestly, we tend to use sine and cosine, and for that one, we tend to have the hypotenuse on bottom. But there's nothing to keep you from using tangent.